All right, let's quickly talk about the X-ray imaging system. In particular, this portion is going to focus mainly on the autotransformer and what the operating console is. So there are three main parts of the X-ray system: the operating console, so where we set our kVp, MA, and time; the X-ray tube itself, which is pretty much the anode and cathode part; and then the high voltage generator, which allows for our kVp, essentially. But let's talk about the operating console first. So again, this is where we set our kVp, our MA, and time. And you can always choose a few other things. Now, because electric power companies can't provide us with exactly 220 volts of power consistently, we have what's called a line compensator. So one good way to maybe remember this is it compensates for that fluctuation we get from the power company. And this is a component connected to the autotransformer, which is going to be the first part of the circuit that we'll talk about. So we moved on from how and why we're getting our alternating current, our electricity here from the outlet. Now we're going to start focusing on how that electricity or that power is transformed for us to ultimately get X-rays. So where it's supplied first is the autotransformer. The autotransformer works on the principle of self-induction. We talked about mutual induction a lot in Chapter 5. And we talked about the fact that it can use a certain amount of energy on one side, radiate that energy out, basically, and cause a different level of energy on the secondary side. So an autotransformer does the same thing, only it can do it with one coil of wire. Now, why we don't always use transformers in all cases, autotransformers in all cases, is because it only allows a very small bump up or bump down. So our primary connections on this side are labeled A and A apostrophe. These receive the input voltage, so give or take 220 volts from that outlet. On the other side, the output or secondary side, we have different areas of connections. So these are kind of called enclosures. So the computer can decide, okay, this RadTech wants this much kVp, so I'm going to use the connections between, let's say, E and C up here. That's just an example. The kVp meter, so what kind of monitors kilovolt voltage in this case, is also found here, but it's not seen in this diagram. So anyway, this part of the circuit or computer plans ahead. It's going to vary the voltage so that in the end, we can end up with our kVp that we want. There in the tube, finally. Further, the autotransformer, again, just like mutual induction, it has a primary side and a secondary side. We get an amount of voltage and a number of turns on the primary side, and then an amount of voltage and a number of turns on the secondary side. Now, the number of turns on the secondary side over a number of turns on the primary side is, again, our turns ratio, which we talked about previously. So if our number of turns on the secondary side is bigger than the number on the primary, you have what we call a step-up transformer. Or what's going to happen is we'll have a step up in voltage and then a step down in current. So if we practice here, we have the connections on the primary side, 600 windings, and it's getting supplied 220 volts. So I want you to practice and decide what the output voltage would be, or secondary voltage, if there were 300 windings between B and E. The computer chose to use this amount of windings on the secondary side. Finally, we'll talk about MA and time. MA first. So, milliamperes are controlled in this part of the circuit. So, on this side, or the primary side of the filament transformer, which is one part of the entire circuit, the X-ray circuit, the voltage received is pretty low. So it's going to get about, give or take, 150 volts delivered from the autotransformer. And the current is going to be at about 0.7 amperes, give or take. Now notice how there are a number of windings on this side and much fewer on this secondary side. What that means is voltage will be greatly reduced, but current will be greatly increased. What we'll end up with is around 12 volts, but 7 amperes instead of 0.7. What I included here as well is from the book. I just wanted to show you, maybe we're thinking about, 40 mass, which it shows right here, 400 mA at 100 milliseconds. And it's hard to imagine how many electrons that's producing. But we set that, and what we ultimately get, in this case, it's showing you it's 2.52 times 10 to the 17th electrons. That's a quintillion or quadrillion. I forget the exact amount, but it's way, way over a trillion. So just imagine that number. It's pretty big. Finally, the timer. It's a circuit component as well, usually wired to the primary side of the step-up transformer. So again, primary side is on, it's what's receiving a certain amount of energy. And this is where voltage is lower and still easily controlled or terminated. Most timers these days are electronic, pretty complex beyond the scope of what we're going to talk about, but just know that electronic's the most common type, and it's usually accompanied by AEC, which automatically terminates exposure when a certain amount of radiation or charge is detected in the Bucky components there. Mass timers is another form of timer, and it's pretty common to fluoroscopy equipment. Finally, the X-ray circuit. Again, we have our auto transformer here. Remember, it's supplying everything so that ultimately when we get here to the tube part, we get what we need.